we discuss about the Daniel cell. Actually, it is a form of galvanic cell. Only the difference part I will explain in the classes. And working or function, the working and function I am not writing this. This is as you have already read in galvanic cell. What is galvanic cell? Same thing you have to write it here. And short bridge is not needed in Daniel cell. So I am explaining working or function. Working or function. Look at. So first thing, look at the diagram. Compare this with the galvanic cell. Look at this diagram and galvanic cell diagram. Slight difference. Galvanic cell diagram, I am roughly drawing the galvanic cell diagram. Look at this diagram. As usual, already we have explained it previously. But since in order to remind you, look at this is the look at 0.1 m zinc sulfate, 0.1 m copper sulfate. Look at this. This diagram, this is galvanic cell. This is galvanic cell and this is voltaic cell. Compare this diagram and that diagram. Look at here, only one vessel is required. Here two vessels are required. Here zinc electrode, copper electrode. This is zinc electrode, immersed in zinc sulfate solution. Copper electrode, immersed in copper sulfate solution. Zinc electrode, immersed in zinc sulfate solution. Copper electrode, immersed in copper sulfate solution. And this inverted U-shaped tube that stands for salt bridge. The inverted U-shaped tube that stands for salt bridge, and this is galvanometer. This is the needle of the galvanometer. Already we have explained it vividly in galvanic cell. But Daniel cell, sometimes he is not putting galvanic cell, instead he puts Daniel cell. So look at the difference. Here two vessels, but here one vessel, here also another vessel. But thing is that here the salt bridge is used in galvanic cell, but here no salt bridge is used. Look at, there is no salt bridge. Very important point. Salt bridge is not required in Daniel cell. Salt bridge is always required in case of galvanic cell. Already we have discussed why the salt bridge is required in case of galvanic cell. Because it maintains the why salt bridge is required in galvanic cell. This diagram is not needed in this part, Daniel cell part. This diagram you cannot draw it. এটা ড্র করিব নাই তাহলে ডানিয়েল সেল নোটস পকাইব এই ডায়াগ্রাম ড্র করিব নাই এটা খালি লিখিও পয়েন্টস কোন লিখিও ফার্স্ট পয়েন্ট the galvanic cell in which zinc copper sulfate reaction takes place is called the Daniel cell. The galvanic cell in which zinc copper sulfate reaction takes place is called the Daniel cell. The galvanic cell in which zinc copper sulfate reaction takes place is called Daniel cell. Look at this is porous pot. In Daniel cell, the salt bridge is replaced by porous pot. देखो जो galvanic cell ले zinc और copper sulfate reaction takes place is तक कोई और Daniel cell. Daniel cell और galvanic cell में difference टा केवल गोटी जिनसे कौन एठी in the Daniel cell the salt bridge is replaced by porous pot. Daniel cell ले galvanic cell ले salt bridge थिबो, Daniel cell ले salt bridge थिबो नाही. एटा ला मेजर डिफरेंस. कौन डिफरेंस? Galvanic cell ले salt bridge present, Daniel cell short bridge is completely absent. Short bridge जगह रे कौन लगाई दिबो porous spot हैला. We will use porous spot in place instead of short bridge. In galvanic cell short bridge is used. In Daniel cell porous spot is used. Clear? So Daniel cell le कौन दिबो porous spot. This is porous spot. This is porous spot. In between this we look at this is porous spot, and in between this we put electrolyte solution ZnSO4, and this part that is copper sulfate. That is copper sulfate solution. That is copper sulfate solution, zinc sulfate solution, and that is copper vessel. That is copper vessel. Clear? That is copper vessel, that is copper sulfate solution, that is zinc sulfate solution. So zinc sulfate solution in between this, that is porous spot part, that is what? Zinc sulfate. Here zinc electrode is immersed in zinc sulfate. Here this is copper electrode. Copper vessel or copper, that copper electrode that will act as copper vessel will act as the copper electrode. And in between this, that is copper sulfate. এইটা হলো porous spot. This is এইটা হলো porous spot. এই ভিতরে কোন আছে জিঙ্ক সালফেট সলিউশন রয়েছে, তার ভিতরে কোন আছে জিঙ্ক ইলেকট্রন। আর এইটা হলো কপার ভেসেল, আর দ্যাট উইল অ্যাক্ট অ্যাজ দি ইলেকট্রন। আর এই ভিতরটা কোন আছে না কপার সালফেট। এই ভিতরে কোন আছে, এই ভিতরটা আছে কপার সালফেট। এইটা হলো porous spot, এইটা হলো জিঙ্ক ইলেকট্রন। এটা কোন ইলেকট্রন? জিঙ্ক ইলেকট্রন। আর এইটা galvanic. This is galvanic. So difference between galvanic cell और Daniel cell or difference. What is the basic difference between Daniel cell and galvanic cell? Here, so this is, look at this is a ভিতরে this এটা হলো porous spot, এটা হলো porous spot। এই ভিতরে কোন আছে জিঙ্ক সালফেট সলিউশন, এটি জিঙ্ক ইলেকট্রোডটা পুরা আছে। আর এই বাহারটা দিস আউটসাইড টা কোন আছে কপার সালফেট সলিউশন। এই বাহারটা আছে কপার সালফেট সলিউশন, এটা হলো কপার ভেসেল। সো এই দুটা ইলেকট্রোড কো কানেক্ট হইছে গালভানিক দুই সাইড, যেরকম কানেক্ট হইছে কোডি গালভানিক সেল, যে ওই ভাবে কানেক্ট হইছে ইন গালভানিক সেল। only distinguishing thing is that there is the porous spot is placed instead of short bridge. In Daniel cell we use porous spot instead of short bridge. Clear? So the galvanic cell in which zinc copper sulfate reaction takes place is called the Daniel cell. In the Daniel cell the short bridge is replaced by porous spot so that the two electrolytes remain separated by the ions diffused through the pore. So look at this point. First paper the galvanic cell in which zinc copper sulfate zinc CuSO4 reaction takes place is called the Daniel cell. Second point, in the Daniel cell the short bridge is replaced by porous spot. Instead of short bridge we use this porous spot so that the two electrolytes remain separated. Two electrolytes a between this inside this a porous spot, this is porous spot, a between this electrolyte zinc sulfate, এই ইলেকট্রোলাইটটা কোন নিয়ে গেল জিঙ্ক সালফেট, এই আউটসাইডটা কোন নিয়ে গেল কপার সালফেট সলিউশন। এই আউটসাইডটা কপার সালফেট সলিউশন, এই ভিতরটা কোন নিয়ে গেল জিঙ্ক সালফেট সলিউশন। Look at this. In the Daniel cell the short bridge is replaced by porous spot. Daniel cell le short bridge ta ko replace kariya porous spot re, so that the two electrolytes remain separated. In the Daniel cell, the short bridge is replaced by porous spot so that the two electrolytes remain separated. But the ions diffuse through the pore. It ions can diffuse. SiO2 ions can diffuse through the porous spot. This ions can diffuse porous spot देखिए ये pass करते हैं. First in this case copper sulfate is taken in copper vessel. এটা হলো copper vessel, এটি copper sulfate নিয়ে আইছে। দেখো নিয়ে আইছে copper vessel লে copper sulfate নিয়ে আইছি, সেটা হলো ক্যাথোড। আর এটা হলো পরস্পর, সেই ভিতরে কোন নিয়ে আইছি zinc sulfate solution is taken inside the পরস্পর। এটি zinc sulfate solution is taken inside the পরস্পর, to it zinc electrode is immersed। চার ভিতরକୁ zinc রডটা বুড়া হইছে, which acts as cathode। সেটা যেটা কাম করবে কোটা cathode হিসাবে। So zinc will act as anode and copper will act as, this copper will act as cathode, this will act as anode। Zinc will act as anode, copper will act as cathode। Clear? Zinc will act as anode, copper will act as cathode। So first is the galvanic cell in which zinc copper sulfate reaction takes place is called the Daniell cell। जो galvanic cell में zinc और copper sulfate reaction टा हबो ताको कोन कहजो Daniell cell। इना फर्स्ट पॉइंट लिखिलो, तापर सेकंड डायग्राम टा करो केना दिस डायग्राम এটা লিখবা দরকার নাই, এটা লিখবা দরকার নাই। নেক্সট পয়েন্ট, ইন দি Daniell cell the short bridge is replaced by পরস্পর। Daniell cell টা রে short bridge replace করব কাহু পরস্পরটা ইউজ হইছি Daniell cell রে কাহা জায়গা রে short bridge জায়গা রে galvanic cell রে short bridge ইউজ হইছি আর Daniell cell টা পরস্পর ইউজ হইছি, so that the two electrodes remain separated but the ions diffuse through the bond। দুইটা ইলেকট্রোড জিঙ্ক সালফেট আর কপার সালফেট সেপারেটেড হইব, কিন্তু আয়নসটা ডিফিউজ হবে, আয়নসটা পরিবেশে পাস করবে। In this case copper sulfate solution is taken in a copper vessel which acts as cathode। এই কেসে copper sulfate is taken in a copper vessel, copper sulfate নিয়া দিব which acts as কোডা cathode। কপারটা act as cathode। Zinc sulfate solution is taken inside the phosphate in which zinc rod is dipped which acts as anode। বর্তমান এইটা zinc টা act as anode, copper act as cathode। পরস্পর is placed in the copper sulfate solution। এই পরস্পরটা copper sulfate solution এ রাখা হয়েছে। পরস্পর is placed in the copper sulfate solution। Next is working or function। Next is working or function। Working or function is same, completely same whatever we have written in the galvanic cell। Galvanic cell যাহা কইতলে zinc electrode এটি কইতলা, as soon as the two electrodes are connected to the two ends of the galvanometer the needle of the galvanometer starts deflecting which indicates that some chemical reaction is already started। Second, zinc atom on this electron loses electron and enter into the solution as zinc 2 plus ion, and then the electrons will move through the insulated area where they give जहाँ जिला whatever galvanic cell जहाँ जिला शेयर हो। आ एटी शॉर्ट ब्रिज जेतु नाही, शॉर्ट ब्रिज पार्टटा तमे लिखिबो नाही, तण galvanic Daniell cell कोन लिखिबो फास्ट ए पॉइंट लिखिबो। जदि Daniell cell इंस्टेड ऑफ galvanic cell जदि Daniell cell कंस्ट्रक्शन पचरला, सो डेफिनेशन एटा डेफिनेशन लिखिबो, तापर फिगरटा करिवो, ए टी पॉइंट लिखिबो। आ वर्किंग और फंक्शन लिखिबो जहाँ galvanic cell ले अछि, सेम एज galvanic cell। Same as लिखिबो same as galvanic cell, same as galvanic cell, same as galvanic cell। क्लियर? same as galvanic cell जा लिखिबो ना लिखिबो, जा galvanic cell लिखला से लिखो। आ शॉर्ट ब्रिज लिखिबो नाही, तण कोन लिखिबो फास्ट डेफिनेशन लिखिबो, ए फिगरटा करिवो, तापर तीनटा पॉइंट लिखिबो। कोडा इन द Daniell cell the short bridge is replaced by phosphate so that the electrodes remain separated, this electroid and this electroid remain separated but the ions diffuse through the pore, Second, in this copper sulfate solution, in this case copper sulfate solution is taken in the copper vessel which acts as cathode। copper sulfate solution copper vessel में आइबो, सेटा cathode हिसाब काम करिवो। zinc sulfate solution is taken inside the phosphate, zinc sulfate solution is taken inside the phosphate which acts as anode, which acts as what? Anode। Then phosphate is placed in the copper sulfate solution। A phosphate is placed in the এই যে পরস্পরটাকে কপার সালফেট এই সলিউশন ভিতরে রাখা যাবে এটা হলো পরস্পর দিস ইজ কেপ্ট উইদিন দিস প্রোডাক্ট কপার সালফেট সলিউশনে এই পরস্পরটা রাখা যাবে এই দিস পরস্পর ইজ কেপ্ট উইদিন দিস কপার সালফেট সলিউশন ক্লিয়ার নেক্সট ওয়ার্কিং और फंक्शन सेम एज galvanic cell जहां लिखा है जी से खाली कॉपी पेस्ट कर दो हैला एंड एक्चुअली सेम एज galvanic cell जहां galvanic cell we have already discussed galvanic cell whatever we have discussed that thing will be written clear this is Daniel cell and you will put the Daniel cell that also 3 marks only here the difference is instead of salt bridge we are using porospot biggest difference in Daniel cell we use porospot in galvanic cell we use what salt bridge and salt bridge ro ja काम दिला सेठी एटी सेरा दरकार नै एटी salt bridge is not needed in Daniel cell तर salt bridge part टा किछि लिखिबो नै salt bridge part कोन से थिंग you will not write anything about this salt bridge part only the definition figure and this part and function or working whatever we have discussed in the galvanic cell with this the electrochemistry is according to the reduced syllabus for this year the given that is completed but electrochemistry is vast thing battery part he has cut out from this syllabus from the previous syllabus also battery is present but now the battery is not present so with this syllabus is over we will discuss some questions previous class we have discussed about the electrochemical series so I think basing upon the electrochemical series and some questions I will give you this and next I will give you some questions for one task you have to solve this here question I am writing why we cannot put copper sulfate solution why we cannot put copper sulfate solution in zinc vessel why we cannot put copper sulfate solution in zinc vessel काहे कि आमे कपर सल्फेट सॉल्यूशन का रखि परिबा नाही जिंक वेसल ले कपर सल्फेट सॉल्यूशन को आमे काहे कि जिंक वेसल ले रखिबा नाही रीजन का होची सेठी गुटे कहै दिला देखो इलेक्ट्रोकेमिकल सीरीज गुटे पॉइंट कहै दिला टू प्रेडिक्ट द रिएक्टिविटी ऑफ मेटल्स an element whose oxidation potential is more that is more reactive धरो एलिमेंट तो दुईटा एलिमेंट सपोज दिया है हमको दुईटा एलिमेंट रो एठी सिंपल गुटे देखो इज रो कपर 2 प्लस बाय कपर 0.34 वोल्ट इज रो जिंक 2 प्लस बाय जिंक माइनस 0.76 वोल्ट लोग is the copper 2 plus by copper 0.34 volt is the zinc 2 plus by zinc minus 0.76 volt एटा যদি কনভার্ট कर दबो this will convert to zinc 2 plus that is plus 0.76 volt is the copper by copper 2 plus that is minus 0.24 look at this is converted to oxidation potential you will not write the answer I will explain it first then I will write the answer of this question so look at this is oxidation potential of copper minus 0.76 341. Oxidation potential of zinc plus 0.76 bond. Look at oxidation potential of copper minus 0.341, oxidation potential of zinc plus 0.76. Clear? So higher oxidation potential kuda zinc, higher oxidation potential, that metal is more reactive. Clear? Higher the oxidation potential, higher the reactivity highest. So element whose oxidation potential is higher, that is more reactive than other element. So zinc and copper is the oxidation potential higher. Zinc, so zinc is more reactive than copper. It is proof. Since we know that the oxidation potential of zinc is more than that of copper, so zinc is more reactive than copper. So if we put copper sulfate solution in the zinc vessel, that zinc will displace the copper metal. Zinc and copper sulfate सहित reaction करिवा एटा कोन करिवा जैनेस सल्फर. लोके ये जो से कौन देखो oxidation potential of copper, oxidation potential of copper minus 0.341, oxidation potential of copper minus 0.341, oxidation potential of zinc plus 0.76 watt. So oxidation potential of zinc is 0.76 watt. Oxidation potential of zinc plus 0.76 watt. Oxidation potential of copper minus 0.34 watt. So current oxidation, which is greater oxidation potential? Oxidation potential of zinc is more than that of copper. Oxidation potential of zinc is more than that of copper. Clear? Oxidation potential of zinc is more than that of copper. Oxidation potential of zinc is more than that of copper, so zinc will displace copper. So zinc will displace copper, but copper will not displace zinc because the oxidation potential of copper is less than that of oxidation potential of zinc. So higher the oxidation potential, that will displace the lower oxidation potential metal. कॉपर और जिंक भितर कार ऑक्सीडेशन पोटेंशियल अधिका जिंक रो ऑक्सीडेशन पोटेंशियल अधिका सेटा कोन करबो लोअर ऑक्सीडेशन पोटेंशियल मेटल को रिप्लेस कर दो तडो एठी हमें जिंक कॉपर सल्फेट को जिंक रे रख परिबा नाही राइट बिकॉज़ जिंक विल डिस्प्लेस कॉपर फ्रॉम द कॉपर सल्फेट सॉल्यूशन एटा सॉल्व सॉल्यूशन ए जो सॉल्व सॉल्यूशन कॉपर टाको डिस्प्लेस कर दबो के जिंक विल रिप्लेस zinc will replace copper. Clear? Zinc will replace copper. Clear? So एटा आंसर ना एवला लिखिबा another explanation, but the answer is like that. Same concept. Answer I will लिखिबा we cannot put very important question for the council exam. You may put this question in this year also. We cannot put copper sulfate solution in zinc vessel. We cannot put copper sulfate solution in zinc vessel because the oxidation OP stands for oxidation potential. After I am writing, because the oxidation potential of zinc is more than that of copper. Because the oxidation potential of zinc is more than of copper. Oxidation potential we cannot put copper sulfate solution in zinc vessel because the oxidation potential of zinc is more than that of copper. So zinc can displace or replace the copper when we put copper sulfate solution in the zinc vessel. Copper vessel. तार रिएक्शन लगा आसीबो Look at we cannot put copper sulfate solution in zinc vessel because the oxidation potential of zinc is more than that of copper. So zinc can displace or replace the copper when we put copper sulfate solution in the zinc vessel. Look at zinc is more reactive than copper, so zinc will displace copper, but copper will not displace zinc because the oxidation potential of zinc is more than that of oxidation potential zinc रो अधिका कार copper थारू तो zinc टा copper को replace करे. Simple कथा जार oxidation potential अधिका सीटा lower oxidation जनका धर 5 अछि और जनका 3 अछि 5 वाला 3 को replace करिवो 3 वाला 5 को करि परिबा नाही जार oxidation potential अधिका the metal whose oxidation potential is higher, that metal is more reactive. That will displace or replace the metals having lower oxidation potential. That will replace or displace the metal having lower oxidation potential. Clear? So zinc can displace the copper, but copper will not displace zinc. Zinc can displace the copper, but copper will not displace the zinc. Clear? So you will write, this is very important question. Most of the time it puts that question. So you will write in this fashion. We cannot put copper sulfate solution in zinc vessel because the oxidation potential of zinc is more than that of copper. So zinc can displace or replace the copper when we put copper sulfate solution in the zinc vessel. You will write this next. If you write this, then definitely you will get 2 marks. And for your more clarity, you can represent the oxidation potential of zinc and zinc oxidation potential 0.761, zinc minus 0.3. Yeah. So oxidation potential of, this is oxidation potential of zinc, this is oxidation potential of copper. Clear? So this is oxidation potential of zinc, this is oxidation potential of copper. Which is higher? Zinc is higher, copper is lower. Clear? This question you will write in this fashion. Another question I am writing. Another question I am writing. Another question, whether whether 1m AgNO3 solution can be stored. Whether 1m AgNO3 solution, whether 1m AgNO3 solution can be stored in copper vessel. Whether 1m AgNO3 solution can be stored in copper vessel, or one m copper sulfate solution can be stored in silver vessel. Whether 1m AgNO3 solution can be stored in copper vessel, or 1m copper sulfate solution can be stored in silver vessel. Answer लिखियो. Since देखो very important सही क्वेश्चन आसला सिल्वर और ये भितर कार रिएक्टिविटी अधिका. Silver, reduction potential of silver and reduction potential of copper. Reduction potential of silver and reduction potential of copper. Silver कहते हैं देखो मोटे दोषी E0 Ag plus by Ag E0 copper 2 plus by copper 0.34. এটা reduction, এটা reduction. So changes to oxidation potential E0 Ag plus by Ag minus 0.80 E0 copper 2 plus by copper minus 0. Look at which has higher oxidation potential? Copper. So oxidation potential of copper is greater than that of oxidation potential of silver. Oxidation potential of copper is more than that of silver. So copper will displace silver. So copper will displace silver. Copper will displace silver because oxidation potential of copper is more than that of silver. So answer lekha since copper will displace copper jar oxidation potential higher seta lower oxidation potential metal को replace करो तो का oxidation potential higher copper oxidation potential higher copper oxidation potential higher so copper will replace silver. Clear? Since a solution of electrolyte since a solution of electrolyte can be stored in metal container since a solution of electrolyte can be stored in metal container if there is no reaction between them. If there is no reaction between them. Since a solution of electrolyte can be stored in metal container if there is no reaction between them. But if we put one MgNO3 solution, but if we put 1 MgNO3 solution in a copper vessel, but if we put 1 MgNO3 solution in a copper vessel, then the following reaction takes place. then the following reaction takes place. Then the following reaction takes place. The reaction copper solid plus 2Ag plus sorry. Okay. Copper solid is oxidized to copper 2 plus silver plus is reduced to silver. Silver plus is reduced to silver. So as copper is button, it is कार oxidation potential का है. Look at copper plus AgNO3. AgNO3 का कौन? Ag plus था AgNO3 put in copper vessel. AgNO3 put in copper vessel. हमें कोई ले कार oxidation potential है. Copper ने silver. Copper has higher oxidation potential than silver. जदि कॉपर आगे ऑक्सीडेशन पोटेंशियल में काट देते हैं रिडक्शन এটা দেখিলে পর E0 Ag plus by Ag plus 0.80 E0 copper 2 plus by copper কেতে plus 0.34 এটা আসিবো minus 0.80 এটা আসিবো minus 0.34 तो कोड ऑक्सीडेशन पोटेंशियल है ऑक्सीडेशन पोटेंशियल ऑफ कॉपर इज हायर देन दैट ऑफ सिल्वर ऑक्सीडेशन पोटेंशियल ऑफ कॉपर इज हायर देन दैट ऑफ सिल्वर चल लगा सो एज कॉपर हैज এটা লিখবেন सो कॉपर हैज higher oxidation potential than silver. So copper has higher oxidation potential than silver. The above reaction is possible. So copper has higher oxidation potential than silver. Then the above reaction is possible. So the above reaction is possible. Tanu hence 1m AgNO3 solution cannot be stored in copper vessel. Hence 1m AgNO3 solution cannot be stored. Hence, 1m AgNO3 solution cannot be stored in copper vessel. Hence, 1m AgNO3 solution cannot be stored in copper vessel. देखो क्वेश्चन नंबर 1 whether 1m AgNO3 solution can be stored in copper vessel or 1m copper sulfate solution can be stored in Ag vessel. बर्तन एटा को धरा Ag vessel एटा ला Ag vessel एटा ला copper vessel. ओके से कहला 1m AgNO3 का हमें हां एटा ला copper sulfate एटा होची से कहूची 1m copper sulfate solution का Ag रखिबा ना 1m AgNO3 टा कॉपर 1m AgNO3 टा को कॉपर रखिबा ना 1m कॉपर सल्फेट टा को Ag रे रखिबा वेरी इंपोर्टेंट whether we put 1m copper sulfate solution in Ag vessel 1m copper sulfate solution in Ag vessel or whether we put 1m AgNO3 solution in copper vessel बता हमें कौन कहले बता कपर सल्फेट टाकू एजिवेशन रखिबा ना एजिएन टाकू कपर रखिबा से कहला कोटा पॉसिबल है बता देखो आमे जानिले जो ऑक्सीडेशन पोटेंशियल ऑफ कपर इज मोर देन दैट ऑफ सिल्वर सो कपर कैन रिप्लेस जदि देखो ए जो 1m AgNO3 टा ए 1m AgNO3 रखबा को कपर रो ऑक्सीडेशन पोटेंशियल टा अधिक त कपर टा का सिल्वर को रिप्लेस कर दो कपर टा का रिप्लेस करो सिल्वर को रिप्लेस करो किंतु सिल्वर रो जेतु लोय त सिल्वर टा कपर को रिप्लेस कर परिबो नाही तळो कोडा पॉसिबल आसी एटा पॉसिबल आसीबो नाही तळो we cannot put 1m AgNO3 solution in copper vessel we cannot answer is we cannot put it like this hence 1m AgNO3 solution cannot be stored in copper vessel so the question is that whether we will put AgNO3 simple two thing whether we will put 1m AgNO3 in copper vessel or 1m copper sulfate in silver vessel बर्तमान हमें देखिए ऑक्सीडेशन पोटेंशियल कहां अधिक कपर रो ऑक्सीडेशन पोटेंशियल अधिक सिल्वर था तब कपर इज मोर रिएक्टिव देन सिल्वर and simply we know from electrochemical series that the metal having higher oxidation potential that is more reactive than the metal having lower oxidation potential जो मेटल रो ऑक्सीडेशन पोटेंशियल अधिक थिबो सेटा अधिक रिएक्टिव जो मेटल रो कम थिबो सेटा लेस रिएक्टिव तब कपर और सिल्वर भितरे कपर रो ऑक्सीडेशन पोटेंशियल टा अधिक तो कपर इज मोर रिएक्टिव देन Ag तो वर्तमान एठी जदी सिल्वर नाइट्रेट टा ए सिल्वर नाइट्रेट सॉल्यूशन को कपर वेसल रखिबा कपर एज बिकॉज़ द ऑक्सीडेशन पोटेंशियल ऑफ कपर इज मोर देन दैट ऑफ सिल्वर सो कपर विल रिप्लेस silver so this reaction will occur this reaction is possible but if copper sulfate is stored in silver copper is more reactive than silver then it is reaction habo na because silver will not replace copper but कोटा possible ho eta possible hobo nai this is not possible we cannot put 1m AgNO3 solution in copper vessel but rather we put 1m copper sulfate solution in silver vessel simple ओडिया गोटे विषय कहूची से कहूची जे आमे 1m copper sulfate solution का silver vessel रे रखि परिबा 1m AgNO3 का copper vessel रे रखि परिबा कोटा रखि परिबा क्वेश्चन ता कहिची आमे 1m copper sulfate solution का silver vessel रे रखि परिबा ना 1m AgNO3 solution का copper vessel रे रखि परिबा क्वेश्चन ला एटा चलो आमे जानु छे वी सिंपल ओडिया देखन कहूची वी आमे जानु जे कपर और सिल्वर भितरे कपर रो ऑक्सीडेशन पोटेंशियल टा अधिका सिल्वर था जार ऑक्सीडेशन पोटेंशियल अधिका सी कोन करबो जार ऑक्सीडेशन पोटेंशियल कम ताकू रिप्लेस करबो तब कपर और सिल्वर भितरे कपर ऑक्सीडेशन पोटेंशियल अधिका तब कपर जतले 1m सिल्वर नाइट्रेट रखिबा तब कपर टा रिप्लेस करबो का सिल्वर को किंतु जदी 1m कपर सल्फेट टा सिल्वर रखिबा सिल्वर रिप्लेस करबो नाही कपर को काहे जी का सिल्वर रो ऑक्सीडेशन पोटेंशियल लोयर कार्डर कपर था किंतु कपर रो ऑक्सीडेशन पोटेंशियल हायर कार्डर सिल्वर था कारण कपर टा सिल्वर को रिप्लेस करिवो सिल्वर टा कपर को रिप्लेस करिवो नाही क्लियर तब सही आंसर है इंग्लिश में लिखा है since and solution of electrolyte can be stored in metal container if there is no reaction आगे देखिबा ए जो मेटल सॉल्यूशन और कंटेनर भितर किछि रिएक्शन होछि कि नाही जति रिएक्शन होछि ताले सेठी आमे रखि परिबा नाही जति रिएक्शन न होछि ताले आमे इजीली रखि परिबा काहे कि देखो सिल्वर नाइट्रेट जब कपर भितर काढियो कपर ऑक्सीडेशन पोटेंशियल अधिक काढो सिल्वर टा तो कपर टा सिल्वर को रिप्लेस करबा किंतु एठी कपर ऑक्सीडेशन पोटेंशियल अधिक काढो सिल्वर टा तो सिल्वर टा कपर को रिप्लेस करि परिबो नाही एटा तो मूल थिंग जेटा लैंग्वेज लिखो तो आंसर टा आसीबो we cannot put 1m AgNO3 solution stored in copper vessel that is the answer so ए वाला लिखियो बेटा आ जदी किछि न पारिबो तबे सिंपल लिख दबो एरम सब काट दबो लिख दबो we know that the oxidation potential of copper is more than that of silver so copper can so oxidation potential of copper is more than that of silver so we cannot put silver nitrate solution in copper vessel because copper will replace silver from the salt solution clear एति ए जदी एटा न परिबो आर अल्टरनेटिव मेथड ला लिखि दियो we cannot put silver nitrate solution 1m silver nitrate solution in copper vessel because the oxidation potential of copper is more than that of silver. So the copper will replace silver from their salt solution. Copper will replace silver from their salt solution, that is a silver nitrate solution. So there will be reaction taking place. This reaction with this hour. Thank you.